Hello students and friends. In this video, we will discuss a typical question involving a free falling body. The given problem is a coconut falls from the top of a 20-meter coconut tree with a zero initial speed. What is its speed 3 seconds after falling? Let g equals negative 10 meters per second squared. Alright, so as usual, we identify the given quantities. So we have the height of the coconut tree, which is 20 meters. Right, so that's the coconut tree. This is the ground. Right, the height is denoted by letter D. We also have the initial speed, V naught, understood to be 0, all right, or that the coconut was dropped from rest. And the acceleration due to gravity, uh, G, is equal to negative 10 meters per second squared. That is what's suggested in the question. We also have the time elapsed, which is t equals 3 seconds. And we are required to find the final speed, all right? The coconut after falling in 3 seconds. So the final speed, v, is our unknown variable. All right, so here are the usual working equations. The first one, v is equal to v naught plus gt. V without the subscript means the final speed. V naught is the initial speed, of course g is acceleration due to gravity, and t is the time elapsed. Alright, the other working equation could be square of the final speed is equal to the square of the initial speed plus the product of 2 gd. Alright, so checking the given data, it looks like both working equations are possible formulas in determining our unknown variable final speed v. So let's begin by using equation number 1. Right, so we substitute the initial speed is 0 plus negative 10 meter per second squared, which is the value of g, multiplied by the time 3 seconds. And we get, solving for v, we get negative 30 meters per second. Alright, but since we are only looking for the speed, in other words, the magnitude of the final velocity, so we say that the final speed is equal to 30 meters per second. And then we proceed getting the final speed, but using the other equation, equation number 2. Right? So when we substitute, since v naught is equal to 0, to get the value for v, we just get the square root of 2gd. We substitute means v is equal to square root of 2 multiplied by negative 10 meter per second squared, and the value for the distance or the height, which is negative 20 meters. But in here, we are treating these quantities as vector quantities. That's why our distance is what we call assumed to be the displacement. All right, the displacement of the coconut relative to the top of the coconut tree. That's why it's negative 20. When multiplied to negative 10, meter per second squared and 2, then get the square root, we will get the value for uh, the final velocity, which is negative 20 meter per second, which uh, when the negative sign is omitted because we're looking for speed, then that would just be v equals 20 meters per second. All right, you will notice that using equations 1 and 2, why do we get two different answers? All right, so once again, two different answers came out in our computation. The first one, v equals 30 meters per second, was the answer if equation 1 is used. V is equal to gt. The other answer, v equals 20 meters per second, was obtained when equation 2 was used. V is equal to square root of 2gd. So, how come there are two answers? Well, these values for v, 30 meters per second, as far as the equation is concerned, there is nothing wrong. Okay? As well as the second answer. It's just that we did not consider if indeed during the fall from a height of 20 meters, how sure are we that the time elapsed indeed is 3 seconds? So neither of these solutions using equations 1 and 2 considered the time elapsed. All right? It is as if we just assume that falling from a height of 20 meters, okay, would take 3 seconds. So that was the mistake that we have earlier on. Okay, we just assumed that the time elapsed is 3 seconds, but we aren't sure. We aren't sure if the time elapsed in falling from a height of 20 meters is really 3 seconds. All right, so we should be able to verify if one of these answers, all right, is a correct answer or an acceptable answer. So let's verify and check. This time we have to determine the time elapsed because we aren't sure that the time elapsed is indeed 3 seconds. All right. So this formula t is equal to square root of 2d over g is taken from the original formula d is equal to b naught times t plus 1 half gt squared. But since b naught is equal to 0, then this is the working formula to find the time t. Alright, so substituting, we have square root of 2 times negative 20 meters divided by negative 10 meters per second squared. So our computed answer for the time elapsed is t equals 2 seconds. So you see, alright, the time elapsed, meaning the time it takes for the coconut to drop from a height of 20 meters until it reaches the ground, only takes 2 seconds and not 3 seconds. So asking the question, what is its speed 3 seconds after, is some kind of a trick, all right, in this question. Now that we have verified that the time elapsed indeed is just only 2 seconds, but since the question is asking for the speed of the coconut 3 seconds after it was dropped from that height of 20 meters, all right? So it is but logical to say that in a time of 3 seconds, long after the coconut has already hit the ground, all right, it is safe to assume that the coconut has already uh, or is already at rest. In other words, its final speed should be equal to zero and not 30 meters per second or 20 meters per second. So this problem shows that in analyzing problems like this, you really have to make sure that the equations you are using, okay, is the most appropriate formula based on the given data as well as on the given situation. Okay, there are problems in physics which sometimes include what we call distractors or tricks. Okay, so what we just done is uh, one way of checking your answer, right, by using uh, a different equation, just like what we did, all right, and of course using our uh, common sense and logical reasoning. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.